right, so picture walk time. Let's take a look at the lesson. What do you think's going on there? Got some words going on, some funny looking people, some electricity, it looks like, the Milky Way, and some other stuff. Oh, those funny little things again. And a mouse and plastline. All right, let's get started. So, inside your brain is a galaxy. Think about that for a moment. Inside your brain is a galaxy. Inside your brain, you have these little teeny tiny things called neurons. And neurons are the building blocks of all learning, okay, and all thought. And scientists think that we have at least as many neurons in our brain as there are stars in our galaxy, the Milky Way. And that is pretty amazing. Do you know why it's so amazing? Well, because they think there's at least 100 billion stars in the Milky Way. There might be more. But if we look at that number 100 billion and we try and understand what 100 billion is, that is 3,000 years in seconds. So in 100 billion seconds is 3,000 years. I mean, that's a long time. That's how many neurons we have in our brain. Okay, and our brains are continually developing. Like every day that kind of processes some new ones. And at the end of the day, they either stay or they go. And I'll tell you more about that another time. So this is our friend, the neuron alien. So this isn't what actual neurons look like. Neurons look a little different than this, but this is a good way to think about it. This is kind of, just kind of makes it a little bit easier. So we're going to picture this neuron alien has a little hand on his head, all right, that we're calling the axon. We have that little eye in the middle, which is a nucleus. And then we have his legs, or her legs there. And those are called the dendrites. And those little dots are called dendritic spines. And that's our friend. And that's kind of what one looks like. Obviously, the real ones don't really look like that. They look more like that next to it. That has the same little parts. But this is a way to think about what's going on inside of our heads when we're thinking. So let's move on. When I have one neuron alien and it wants to talk to the neuron alien right next to it, it takes its little hand and it makes some energy there and it touches, let's go back real quick, the dendrites, okay, and the dendritic spines of the alien next to it. And it goes, hey, how's it going? Good to see you. Nice to meet you. Zap. And there's a little bit of electricity that goes from that hand to that foot. And then it kind of goes up that foot into the other one's hand. And if we look on what's going on scientifically, in the very in between that, where the axon and the dendritic spine is touching, the little piece of energy goes across it, and that's called the synapse. Okay, so you have that little hand, it's touching the little foot, and a little piece of energy goes across that on something called the synapse. And if we look in on that synapse, the very first time those two neurons meet, there's a little bit of electricity that passes from one to the other. But the more and the more they talk to each other, kind of like good alien friends, the quicker and the better that relationship comes. And the more that electricity goes across and bounces, and the faster it becomes, and the better it becomes, and the bigger it becomes. And that's what practice is. Okay, so at the very beginning, it's kind of slow. The energy kind of bounces a little bit over. But then the more and the more and the more these aliens talk and hang out together, the bigger and the better and the faster it becomes. Brain dump time! So that was a lot of information, right? So this is a picture of a bunch of aliens hanging out together, and they're touching. And one hand touches, one of the arms touches the axons, touches the dendritic spines of the one next to it, and energy travels up. And then that one touches another one, and then that one touches another one, and then that one. And so you have this flow of energy. And that's called your thoughts, which is gosh darn amazing. You have all this energy going in your head all the time, all this electricity going through. And the more you use something, it becomes linked together. Okay, so the first time it happens, there's a little bit, maybe it's just two neurons going together, and then a boom, 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 boom. So everything that you do and everything that you know is something like a brain link. Okay, it's kind of this group of information, group of moves maybe. If you do Rubik's Cubes, that's a bunch of moves. Okay, soccer, moves. You also have to know offenses, defense, all this stuff is happening. What's your position? Where am I? What's going on in the game? Where's the ball? All of this stuff are different links. It's all connected together. Reading, I know my letters, I know words, I know how to sound things out. I'm using all these strategies that I'm learning. Writing, language, everything that we can see and everything that we do is linked together by these things. And the more we use it, okay, the more we practice, the stronger our brain links become, the quicker it becomes, the easier it becomes to recall it. Like I told my class the other day when they took the MAP test, there is nothing easy or hard. Okay, you either know how to do something or you don't yet. Okay, so this is where this learning becomes. Okay, we use our neurons. Okay, and the more we use those neurons, they stick together. There's this very famous saying amongst neuroscientists, and they say neuroscientists are those people who study the brain. They say neurons that fire together wire together. Okay, so whatever you do, okay, and whatever you're focused on, neurons start to get together and become stronger. So that's going back to the other lesson about habits and what we do with our time. That's what we get better at. Okay? And the reason we get better at that is because of those brain links. And so whatever you choose to do, your brain is focusing and wiring and getting stronger on that thing. Okay. Now we're going to talk about a metaphor. We briefly talked about a metaphor last time. Metaphors are just a really great way to understand our learning. If we can compare one thing to something else, it not only helps us to learn, it helps us to teach other people. If we can create our own metaphor. So again, a metaphor is taking one thing that's here and saying it's kind of like this thing over here. See this thing I'm talking about? It's kind of like this. Okay, so our metaphor today is this idea about a mouse in a field, or mice in a field. They scurry about. Maybe the first time they're just out on their own. They kind of develop this little path of where to go. It's hard, right? The grass is up. Maybe there's things going on. They're terrified. They're going through. They're probably terrified every time, to be honest, of owls and whatnot. But it's trying to go from one place to the other. Okay, and it's probably slow going because they've never been there before. Okay, and all the grass, the path there's stuff in the way. But the more and the more this little mouse goes from one area to the other, the easier that path becomes. Okay, and the quicker the mouse can go, and the better it knows its way around. And so that's a metaphor for our brain links and for our learning. Brain dump time. all of this is called this idea of being able to learn, being able to change how our neurons talk to one another. All of this is called brain plasticity. And your brain plasticity, this is something that happens your entire life. They used to think that once you hit 18, your brain was fixed, no more learning. That's just not true. We know that's not true. People can learn. I mean, I've learned Spanish in the last, 10 years of my life. And so we all have this ability for our whole life to learn and to create new brain links and to do all of these wonderful, wonderful things when it comes to learning.